In most industrial facilities, you have dozens of devices that all need to share data with each other, and running individual cables between every single one of them gets complicated really fast. CAN bus actually solves that by letting every device communicate over just one shared pair of wires. So instead of one device sending a message directly to another, each one simply broadcasts its update out to the whole network, things like temperature readings, motor status, and fault codes. Every device on that wire sees every update and just ignores the ones that it doesn't need. So what happens when two devices try to send at the same moment? Well, CAN bus has a built-in priority system. The more important message goes first, then the other one waits and tries again automatically. This way, you don't have any crashes, lost data, or manual intervention. And because machines are electrically noisy, every message gets checked as it travels. If something looks wrong, it gets sent again automatically. The network fixes itself without you doing anything. Now, in just a moment, we're gonna cover the wiring mistake that causes most CAN installations to fail, but before we jump into that, just stick with me here because this next section will keep you from a lot of costly troubleshooting down the road. So in larger installations, you sometimes need to split one CAN network into two separate sections, like when you need to isolate a noisy area, extend the distance, or make one section easier to troubleshoot on its own. And when that happens, you need a bridge that connects both sections so they still work together as one system. The ICP-USA I7532 does exactly that. It sits between the two sections, keeps problems on one side from affecting the other, and even lets each section run at a different speed if your setup needs it. So if you're interested in reading more about this module, the link will be in the description below. Now, the part that trips up most installations is wiring. The right way to do it is to run one continuous cable through the area and have each device tap into it with a short connection along the way. The mistake that most people make is running a separate cable from every device back to one central point. That layout creates interference that shows up as random dropouts and is very hard to trace. The other thing to get right is that at each end of that main chain, you need a small resistor to stop the signal from bouncing back. If you miss one of those, you'll see the exact same random dropout systems, so always make sure that you're checking both ends. Thank you so much for watching this video. If you have any questions regarding any of the information that was covered today, you can reach out to our team at sales@icp-usa.com, or you can head straight over to our website at icp-usa.com. And if you did enjoy this video, please do not forget to like and subscribe, as it really helps out the channel.